Good morning. Good afternoon. Hello. All right, welcome to the video. So this is last year. You guys aren't 7th block. All right, so in an effort to make these short, sweet, to the point, no staples. Lily. Are you ever gonna take all the numbers off the board? It's really fun. Oh yeah. Sorry. I'm sorry. No, I forgot. I would have noticed once I looked up. All right. So let me pass out these notes. Really short, sweet, to the point. I will say for Unit 7, this is definitely an application of integrals chapter. So a lot of the time we're going to be either integrating with a calculator, which is exciting, or integrating or kind of doing what's called setup but do not evaluate. So you would set up the integral but actually not figure out what the number is. No, you're good. Oh,
Keep your hand up. It's like you flinch and you get slapped.
No, all right. Also, before we get started, I just like to say the dates about 1,000,000 times. Your problem set should be done today. Hopefully, you have it in a spot where you can finish it by the end of class. You're going to turn that in today, but just to note, it's not on second quarter grades. If you want to change your second quarter grades, you are doing any kind of makeup work, reassessments, corrections. Those are all due by Friday at 4:03 p.m. I will be leaving the building at 4:03 p.m. So make sure it's in by then. And our test, that is Wednesday, November 2nd. Because you guys have a 4-day weekend. Yes, what did I say?
November.
Oh, that's my birthday. That's why I said that. Mason. On the 2nd? All right. I would take the test at some point. Wait,
as well.
why?
I'm going on
I'm
college
going on
visits.
vacation, bro.
I'm
not
gonna
gonna
be
be
in
here.
Florida. I'll be right here in this classroom.
I'll be here. All right. If you are not going to be here that day, recommendation, it's obviously not super important that you take the test on time, but it's always advantageous if you can take it before we do round 2 as a class. So try to take it as soon as you get back. So let me input these notes. 7.1, area between two curves. All right. So we have found the area between a curve and the x-axis. Now we're going to find the area between two curves. It is not a mesmerizing thing to do. The rest of this unit, though, is very mesmerizing. We are going to be taking stuff and building cross sections on it, rotating it. If you remember this unit from last year, it's honestly just very, very cool looking, and you will feel smart doing it. And it's a lot about setup. So let's label a picture. All right. Do you notice these first 3 pictures are all the same picture? What? All right, I'm gonna label some. I'm gonna label this top curve f of x, so that's that parabola. I'm gonna label this bottom curve g of x, so that's the thing that looks like trig. I'm gonna drop some verticals from these intersection points, and I'm gonna label the x values. There we go. Words are hard today. A and B. I was doing word problems this morning. That's probably why my math language is not great. All right. So I'm gonna label them A and B in all of the pictures. All right, so my goal eventually, and it's going to take us about 2 seconds to get to that goal, is going to be to find the area between the curves f of x and g of x. Oh, that is too thick. So I want to find this bad boy. So let's take the 2 seconds we need to figure this out. All right, we know how to find this. All the way of f of x all the way down to the x-axis. How do I find area on a graph? You integrate. All right. If I'm finding the area under f of x is going to be my integrand. What will my bounds be? 6. All right. Now, I would argue that to find this green part, I want to get rid of the stuff that's under g of x, right? So let's find a way to evaluate that. What do you think that's going to look like? Okay. So g of x is my integral. Still going from a to b. And do you agree with Brandon? He's giving away all of the notes for today. That if we subtract those two, we get this? Yes, that's literally it. Wow. Problem set gets a little bit more interesting. So a couple ways to write this. We can do this as two separate integrals. So the integral of f of x dx from a to b minus integral of g of x dx from a to b. But oftentimes, we're going to combine this into one integral from a to b of f of x minus g of x. Let's give some context of what f of x minus g of x is. That is the vertical distance between these two curves. So it's almost like we're creating a new function where that function is the height of the distance between these two curves. Now, we'll never actually look at that function, but that vertical distance is kind of your height that you're talking about if you think back to like Riemann sums. Now, yeah, so this distance right here, f of x minus g of x, is like this distance right here. So you're looking between the two curves. So it's almost like we're just looking at that height as the height of each of our, like if you were doing Riemann, the height of each of our rectangles. All right, so I'm going to use pretty consistent language throughout this unit because that distance happens to be pretty helpful a lot of the time. So I'm going to be usually calling this top minus bottom because we can oftentimes reference which function is the top one, meaning vertically higher, minus the bottom, meaning vertically lower. We'll also talk today about doing this in terms of y, so we might be talking lefts and rights. But this is pretty consistent language that we'll be using throughout Unit 7, so I just wanted to reference what I'm talking about. So we're going to go through a few problems today, I think 6 to be exact. The first couple we can integrate, but we are going to be pretty selective on which ones we integrate because the point of this unit is to be able to set up these integrals and not actually to integrate to get the answer. So one thing you're going to notice is we're going to focus a whole half ton on the setup. We're not going to integrate that many of them. All right. So let's talk about this one. We are going to find the area of the region between the graphs of secant squared and sine x between x equals 0 and x equals pi over 4. Anyone know what those graphs look like between x equals 0 and x equals pi over 4? All right, let's grab some calculators and graph them. So grab a calculator if you need it. I'm going to pull mine up. We're going to need it later today anyway, so grab a calculator. Should have said that at the beginning of class. TI Smart View.
Do you have a pen or a pencil I could borrow?
Pretty much this. Ready?
When I got this calculator, I said, what is my favorite physics program? I forgot.
Nice.
Oh God, back to here.
Yeah. I need to get a new one of those. No. Got mine. Thank you though. I also have this. It's a powerful. It does work. It's just hard to use. All right, I have a question. I want to graph secant squared. There's not a secant button. How do I graph secant squared? That would be great for tangent.
It's 1 minus 2.
What?
1 minus 2.
That would be arcsine. What is secant equivalent to? 1 over cosine. So we're going to do 1 over cosine x squared. You can't put the squared in the middle of the cosine like the notation on your paper, but if you close your parentheses, it will square the whole cosine. If you're scared, put it in parentheses and then square it. What was the other graph? Sine x? What? Y equals at the top left. Sine x was the other one? All right, now I have a pretty specific window that I'm interested in on this graph. When I say specific window, I mean that x equals 0 to x equals pi over 4. So I'm going to go change that window. I'm going to go window. I'm going to type in 0. And I'm going to type in pi over 4. The pi is on top of this like caret button right here for the powers. It's blue, so I'm going to press the blue button first. And do pi over 4. Now I'm going to quickly investigate what this looks like. I'm probably going to change my y min, y max, just because I think these are pretty silly graphs. Yeah. Let's zoom in a little bit. That looks really stupid. So maybe like -2 to 5 or something. I'm just going to adjust my y min and y max to make it look a little bit prettier. That still sucks. All right, what do we think? -1 to 3? If your graphs look remarkably flat, make sure that between AP Physics and now you change your graph into radians mode. All right, there we go. That looks a little better. So I'm going to try to recreate this graph on my paper. We want it in radians. So every single time you use the calculator in this class, it's going to be a radians mode. Yeah.
How do you make it less flat?
So I'm just changing the y min, y max to be kind of closer together so that I can kind of stretch the graph this way. I had it from my question. It said x equals 0 to x equals pi over 4. Is this number. It just calculated it for me. So I put it in pi with the blue button over 4. Yes, ma'am. What?
When we're on the y menu.
Yeah. I have -1 to 2 personally, but you could go closer, farther away. Doesn't matter. Oh, sorry. Sorry. Yes, I have 1 over cosine x squared. That is my secant squared, and y2 is my sine x. All right, we all caught up? Yep, so I'm just graphing the two functions it gave me, putting some bounds on it. Mostly, the only real reason I need to look at this is I need to know which function is the top function and which one is the bottom function. So my top function is the secant squared. My bottom function is the sine x. So I'm going to go to my paper and I'm going to kind of just do a quick sketch of this. Now, when a mathematician uses the word sketch, that means I'm not going to go too crazy on the detail. I just really want to get an idea of what this picture looks like, but I don't need to go crazy. So here is what my sketch is going to look like. And I'm going to cut it off here and label this as pi over 4. All right. If you like, you can color in your little region. We're looking for the area of this region right here. Now that is between the two graphs. Other language you'll probably see today is bounded by those two graphs and those x values. So kind of similar language there, but you get the idea. So I'm going to set up an integral because we're talking about area. That makes sense. We've said integrals are area before. What is my top function here? Secant squared x. And I'm going to subtract the bottom function, which is sine x. I'm going to throw my dx on the end. Again, that statement that I just wrote as my integrand, the secant squared minus sine x, that's representing the vertical distance here. I essentially want to add up all of those little vertical distances. Glaringly missing are my bounds. I'm going to go from 0 to pi over 4. Yeah. Exactly. And the nice part is, we'll talk about that in a second, actually. All right, this is probably the only question we're going to integrate by hand today. So we're going to do 2 of them, but this is one of them, so we can practice our trig. Anyone know what is the integral of secant squared? Tangent. Good. Tangent has a derivative of secant squared. What is our integral of negative sine? Cosine, and that's going to be positive cosine there. I've integrated, but I haven't plugged in my bounds. So I've got my vertical bar with my 0 and pi over 4 on it. And now I'm going to plug in my bounds. All right, ready? Is your unit circle up here?
No.
Tangent of pi over 4. 1. Cosine of pi over 4. Square root something. Square root of 2 over 2. All right, ready? Tangent of 0. 0. Cosine of 0. All right, those don't need to be fast. They should be faster than that. Yep, subtract between the bounds. All right, anything good happening here? The ones will cancel. All right, so our answer is the square root of 2 over 2. Now, this unit offers a pretty good opportunity to be able to sanity check your answer. What I mean by that, our answer is positive. Should it be? Yes. We are finding not signed area anymore. We're finding straight up area. So if you get a negative answer, you did something wrong. And most likely the thing that you did wrong was you subtracted in the wrong order. So if you get a negative answer, first thing you should check, did I flip-flop which was the top and bottom function? Also, we can do kind of a size comparison. This is a little bit less than 1 because square root of 2 is less than 2. And this is a pretty small area. Remember that pi over 4 was like 0.7 something, and we were only going up to 2 on our graph. So the idea that this is a pretty small number is probably a good thing. If I got something like 10, I would be a little concerned because that area was much smaller than 10. So you have a good opportunity to kind of sanity check and make sure those things are correct. All right, let's get some more interesting problems going. So I want us to read this question and think about what information did I give you in the first problem that I'm not giving you now. So I want to find, all right, sorry, this hallway, man. Is it always like that? Yes, lunchbox are worse, but always. Always. Yeah, so we're really going to be focusing on getting to this point. There will be a couple of problems on the Unit 7 assessment where I'm going to ask you to integrate, but most of the time they're going to be setting up and either using a calculator or just leaving a setup. All right, we have find the area of the region bounded by f of x equals 2 minus x squared, g of x equals negative x. What is kind of glaringly missing from this problem? Bounds. So how do you think we're going to find the bounds? All right, let's start with a graph and see what we've got. So 2 minus x squared, what does that look like on a graph? This is something I would be comfortable giving you without a calculator. All right, where does it go through the y-axis? All right, 2. I'm going to kind of give a couple of points. And it does something like this, I guess. What does negative x look like? Okay, so we've got a line. Where is its y-intercept? 0, 0 at my origin, and counters right. We have a slope of -1. So I've got something that kind of does this. So I think I can see what area they're talking about. We're bounded by, so think of bounded by as like a fence, or like if you're in this room, we are bounded by the walls, the floor, the ceiling, the door. We're talking about this area in here. I'm making a big deal of that because surprisingly enough, sometimes the graphing and the just finding your area can be the hardest part in the question. So I can kind of see what points they're talking about for these bounds. I really want to go between the leftmost and the rightmost point here. We're talking x values, but I don't necessarily know exactly where those are. Can anyone think of some algebra I could do to find those intersection points? Austin, what do you got? Perfect. If I want to figure out intersection points, an easy way is to set these guys equal to each other. You could find them on a calculator by doing your intersection on the graph, and we're going to practice that later. This one, though, is one I would be very comfortable making you solve via algebra. To do that, I'm going to move everything over to the right-hand side of this equation. I'm choosing right-hand side to get the x squared to be positive. Personally, that's easier for me. And let's check. That will not be a plus 2. Sorry, I need to subtract 2. Let's check your factoring. I'm going to give you a hot second to try to factor that and find my 2 intersection points. You could also sanity check those on the graph. You can probably see what one of them should be. Minutes in. Are you guys in algebra 2? Hallway combos. All right. Did you guys factor? Minus 2 plus 1. So x equals 2 and x equals -1. Liking the feeling of that because this looked like -1 from my graph and this looks a little farther. So we're claiming that this guy is 2. Feels good. Kind of like it. So let's talk about a couple of ways. We're going to kind of set up but do not evaluate this one, or we can evaluate it on our calculator if you would like. There are a couple of ways that I can set up if my problem is given to me like this. So let's talk about both ways. What would our bounds be? -1 and 2, and I do want to go from lowest number to highest number. If I'm looking at my graph, my distance between, what is my top function? F of x. Now, I can either write f of x, or I can write 2 minus x squared. Either way is fine. If you're on the AP test on like a free response, I would highly recommend using like f of x instead of saying like Natalia San Giuliano. You could just say Polly. That's fine. So then, what are we subtracting? G of x. So you can either say you're -x, that's fine. You could also simplify here, that's perfectly fine. Or you can use his nickname. Instead of Isabella San Giuliano, you can say both. Nicknames. So this is very nice when you're working on a free response to use the kind of function nicknames because it just makes it cleaner. It makes it less likely to make a typo. You're going to see one we do in the calculator section has a really kind of rough function. So it's super nice to use those shorthand. All right. To save time, we're not going to integrate that one. So if you saw the directions set up but do not evaluate, you would just leave it like that. Find usually means we're going to actually find the area, but we'll be lazy. All right. Can you guys, for me, actually, let's just do these together. All right. So on the AP test, oftentimes, because you may be thinking to yourself, wow, I'm not quite as familiar with all of these graphs as you seem to be. That's perfectly fine. I would expect you to be able to graph something like this, but sometimes they're going to want to give you a more interesting graph to look at. So what they may do is give you some information, but not all of it. So here we have a region R in the first quadrant. Cool, that makes sense. And we've got it enclosed by the graphs of 8x cubed and sine of pi x. They're shown in the figure. One thing they are not is they are not labeled. This was not a calculator question, so we would have to be able to figure out which function is which based on our knowledge of the graph. So I would like you to take about 30 seconds, talk to your neighbor. I want you to decide which function is f of x and which function is g of x. I'll talk to you in about 30. Oh my goodness. All right, you got an answer for me? All right, I have a claim. The bottom one is f of x. The top one is g of x. Does anyone agree? All right, can anyone give me any sort of justification as to why? Okay. Yeah, so we might know a little bit about sine, that he kind of travels up straight out of the origin. Brandon's knowledge of 8x cubed, that slope getting really big, really fast, has a reason for f of x. Anyone else have some ideas? All right, yeah, I kind of base mine off of the sine of x, but whatever knowledge you need to be able to distinguish between those two graphs, that's the kind of knowledge you're going to need to use in these questions to make sure you know which functions are which. So let's go ahead and let's set up our integral. This question does say find. This is the last one we're going to actually do by hand today because I want to help you practice for something that is on your problem set. So let's set it up. I'm not going to set it up with f and g. I'm going to actually use the full names of the functions. Which function will come first in my integrand? The sine one. So I'm going to be doing top minus bottom. So I'm doing g of x minus f of x, which is going to be my sine of pi x minus my 8x cubed. No, so yeah, if you're wondering where I put the line, I'm drawing this because we're going to be drawing this a lot next class. It's going to be really helpful then. I'm just picking a random point that's inside the region R. So if you think I have more of a reason, I do not. I am not being clever. Yeah, forgot to mention that. Thank you. Yeah, bounds. What are they? Yes. So 0 and 1/2. Now notice that that 1/2 is labeled. You don't want to assume anything based off the graph. If they want you to use a point, they should label it. If it's not labeled, you want to check to make sure that's actually where you think it is. All right, this last one we're going to integrate for a very specific reason. I have used this question on many, many tests, and every year I do, I get to highlight a ton of things that don't have to do with actually finding the area of the graph. They have to do with integrating. So I want you to look at this integral, and I want you to predict. Every year, I highlight the same thing on about at least half of my students' papers, and it's going to be something that I could highlight on your upcoming test. What mistake do you think people are going to make? All right, so what is the deal with the pi? What do you mean? Right, so I need to do, and Tali's adding the words that I needed, this means a u-sub. Now, we've done a lot of these u-subs in our head. If we do u equals pi x, our du would be equal to what? It's going to be pi dx, but I know why you guys are saying 1 over pi. We're going to want to move that over to the du side. So a lot of you have been doing these kind of in your head on the problem set, thinking of more of like a reverse chain rule. We're going to need a 1 over pi out in front of whatever integral that we're doing. Like a 2 or a 3, we're talking 1/2, 1/3. All right, so what did you guys say the integral of just the sine part was? Negative cosine. I'm leaving a space so I can put my 1 over pi that we talked about. And then thoughts on the 8x cubed part? 2x to the what? All right, someone besides Lily who just said 2, where's the 2 coming from? All right, the 8 divided by 4. And I'm going from 0 to 1/2. All right, let's have some trig fun. Love it, love it. All right, so I'm going to write it out really deliberately first to make a point. So pi times 1/2 minus 2 1/2 to the 4th minus . All right, so this was a free response question on the AP test. This answer that I've written, perfectly legal. All right, as we get forward to the AP test and practicing for free responses, I'm going to keep reminding you, because simplifying is just a waste of time and an invitation to take your points away. You can leave any algebra unsimplified. You can also leave any trig unsimplified. As long as I could plug it like into Desmos and it would give me a number, you're good to go. That being said, we're going to sometimes continue to simplify in the notes just to practice for multiple choice, because there we're going to have to simplify. So let's talk some of these numbers. We're talking here cosine of pi over 2. Anyone know that one? All right, so pi over 2 is right here. Cosine's the x is 0, so all of that guy is gone. Oops, that is not the pen I wanted. All right, what's 1/2 to the 4th? No. 1/16, we're talking 1 to the 4th over 2 to the 4th, so 2 times 1/16, that's negative 1/8 out of the first set of parentheses. What do we got for cosine of 0? 1, so that's a plus 1 over pi. And this guy right here is just 0 as well. That is all right. So if we look at this, the reason I wanted to simplify this is we want to see if this is a positive value. Does anyone know? Is this a positive value? How do you know? I agree with you. Okay, so this is, what number is this about? It's about 1/3 minus 1/8. That is a positive number. Also, look at this scale here. We're talking between 0 and 1/2 and 0 and 1. So like this entire rectangle right here has an area 1/2, because 1/2 times 1. So this should be a pretty small number. 1/3 minus 1/8, that sounds pretty good. James.
You have negative 1.
I would have a problem. So
You're technically like, you're adding it in infinite numbers, you can't let.
So yeah. So I should be getting a positive number because this is a positive area. So if I get a negative number, because you're adding infinitely many types, I get what you're saying. So if that happens, if you get a negative number, the first thing I want you to check is the order of this. That's usually the mistake. Then check, are your bounds in the right order? Did I plug my bounds in the right order? Every single answer in this unit, that's a straightforward question, because we're going to be finding area. Next class, we're going to be finding volume. Every single answer should be positive unless the question is like asking you to go backwards. All right, let's do a couple more. When do we get out of this class? 53. If I am still talking at 12:25, who's considering themselves sassy and rude today? James, tell me to shut up if it's still 12:25. All right, now the cool part, I can actually do this in terms of y as well, meaning I can go from kind of right to left instead of top to bottom. So I want to show you how to do that with one that works both ways and then one that only works one of the ways. So if we were doing this right now, hopefully you guys know this line would be y equals 6, and this one would be y equals 2 square root of x. I could certainly do this problem by doing the top function 6 and subtracting the bottom function 2 root x. If I were doing this question in terms of x, what two x values would I use as my bounds? 0 and 9. I love it. We're going from 0 all the way over to 9. If you ever get confused with your bounds, you can always take your pencil and kind of slide it along the axis that you're working in, whatever letter you're working in. So sliding along the x-axis, I can go as far left as 0, as far right as 9. The cool part is I could actually orient myself the other way as well. And sometimes this can be a little bit cooler. So notice here, if I go from left to right instead and kind of move that blue line up and down, my bottom function is actually the y-axis. So my kind of integrand could be a little bit easier. That being said, if I go that way, I have to use the letter y in all of my integral stuff. So I would have to get this function to be in terms of y. I could do that by dividing by 2. And then how do I get rid of a square root? Square it. So I could get y squared over 4. I could use that as my top function. And then this line right here, my y-axis, is my bottom function. What line would that be equivalent to? Like what thing could I put here? Say it louder and prouder. 0. It's like the x-axis would be 0, the y-axis is 0. So this is actually kind of more of a pure integral here. What thing would go at the end? Would I put dx? I would put dy. I'm working in terms of y. Also, I would need bounds that go with y. So what would my bounds be? 0 and 6. Okay, so if I use this top function, if I'm trying to work in terms of y, meaning I'm moving my line up and down to correspond with those y values, I need this function to be in terms of y, meaning I need x equals stuff with y's in it. So to do that, I decided to divide by the 2 to move that over, and to get rid of the square root, I squared both sides. So squaring the top, y squared, squaring the bottom, 4.
I see. Y
Exactly. And then our bottom function was just the y-axis, so that's x equals 0. Now, you might be saying, why would I ever want to do that? That seems like a silly process. I don't like that. So here is why. If I look at this graph, if I'm trying to find a consistent top and bottom function, if I choose 2 different places to make my 2 vertical lines, one of these has the blue function as the top, the red function as the bottom. One of these has the red function as the top and the red function as the bottom. I could split this into 2 different integrals, but that sounds like a lot of work.
True.
Also, look at the way our functions were given to us. They said x equals something with y's in it. So they're even trying to hint to us, hey, maybe think about if you could go in the other direction. Now, if I look at trying to orient the line kind of horizontally, if I take my pen and move it up and down, consistently, the red one is on the right-hand side and the blue one is on the left. This is always our top as far as like the x's go, if we're going top to bottom, because our bigger x values are on this side, smaller on that side. So just like bigger y values, smaller y values, bigger x values, smaller x values. So let's see if we can write this integral. All right. Which one do you think is the top function? Is that parabola, the 3 minus y squared, or the y plus 1? 3 minus y squared. And I'm going to subtract the y plus 1. As a note, those parentheses are really important because we're subtracting. And I'm done, right? Oh. What are the bounds? All right, let me ask you a first question. Should I be using x values or y values for my bounds? Y. So what is the y values that I should be using for my values? -2, 2, I think 1. Now, if your graph had not been quite as accurate as mine is, maybe I didn't have the grid lines, can you remind me one more time how I could have checked that those 2 numbers were correct? I could set these guys equal to each other to find the bounds. Again, simple factoring. Yeah, you could do that too.
So you could, in theory, solve this via x.
Yes. So, and sometimes you're going to get a function. So I could solve that this equation for y and get it in terms of x. Sometimes there will be functions where you can't solve it. So you would be forced into using it in terms of y. Yeah. Yep. Mm-hmm. All right, the last question I want to do today, and then I will actually be done. And then I would probably, again, move everything to the right and vector. This one looks very similar, but I think it's y plus 2, so that's your negative 2 and y minus 1. All right. So the last question on this one is slightly more interesting. Whoa. We're going to do it two different ways, but also, are those functions that you are really feeling like, hey, I would love to integrate these? No, this is a calculator question. Yeah, this is a calculator question. That is mostly because of that E. That E, we actually don't know how to integrate that. I don't know how to integrate that. So we are going to do a calculator question here. Now, these calculator questions, I'm going to show you a lot of tips and tricks throughout this unit because these integrals tend to get a little bit messy. We're going to start having pies in our integrals. We're going to start squaring large things. So we're going to want to use our calculator and some of the shortcuts in it to our advantage. What I would suggest in any calculator question like this, first thing you do, if you see you have two functions that are big and nasty like this, let's immediately go and put them in our y equals. So will everyone follow along? This one has a lot of good calculator info. Will you try to do this with me so you get a little muscle memory going? All right. So I'm going to try to type these in. And they're nasty. 1 plus x plus, oh, that's not it. It doesn't, as long as you remember which one is which. So sometimes what I do is I like to label them on my paper. That's actually a good idea. So I'm going to label y1 and y2. That's a really good thing to do if you're on the AP test and you're like moving between parts. Oftentimes, this used to be, Unit 7 used to be one of the more popular AP test questions. Hasn't been in recent years, but that doesn't mean they won't come back. All right, 1 plus x plus e to the x squared minus 2x and x to the 4th. It's so annoying to type on this calculator.
I feel like it's bad that I've gotten to a point where I saw this and I was like, oh, well, you is definitely.
It would be. It wouldn't work, but it would be. All right. Also, I remember we changed our window on our last question. So instead of just pressing graph, I'm going to go and press zoom 6. That's the standard window, so I can get a picture. So as I'm typing in and I'm looking at this picture, the first thing I'm going to do, since they gave me a picture of these two graphs, is I'm going to make sure that it looks kind of like that picture. Now mine's a little zoomed out, but I do see that those two regions there look like these two regions right here. All right. One difference. It doesn't? Zoom and then the number 6. All right. Everyone check to make sure you plugged it in, right? I've only got 10 minutes before I'm being told to shut up. That's good. I know, right?
I got it.
All right.
I had my 2x with the square.
Gotcha. All right. So what is one significant difference between this question and the questions we've been doing?
The area looks a little wonky.
Yeah, the area looks wonky because there's two of them. Also, let's go ahead and can you guys tell me in... Yeah. So I noticed that the blue function is kind of this parabola-esque thing. That was my E function. It's definitely not a parabola, but it looks more like one than the other one does. This red guy, the kind of swoopy guy, is our quartic function. So I'm going to label them as such. So this guy here is our f of x. This guy here is our g of x. Now, because we have two different areas, what do you notice is happening? I know that's a big question, but I think Yeah, so our top function and our bottom function are switching. There are two ways to deal with this, one of which you can do if you have a calculator, the other you can do whether you have a calculator or not. So I'm going to show you the harder way first, and then I'm going to show you the way that's easier if you have a calculator. So the harder way would be to break this integral into two different pieces. Find the area of R and then find the area of X. So I could find R first by doing g of x minus f of x. And then adding on the other region S, that's f of x minus g of x. Glaringly missing are my bounds. Yeah, I tend to repeat the same words. Yeah, so R being the region, this would be the region X. What do you think the bounds are for R?
0 to 1.
0 is correct. I'm going to tell you 1 is not. We cannot assume that this intersection point is at 1 because it is not. And that will make our answer wrong. So let's talk about how to do this on the calculator. Yeah. So I could try to trace and get close to it, but I want to know exactly what that intersection point is. So this is like the one thing you need to be able to do on the test as far as like algebra on the calculator. We're going to go second calc. Which one should I choose? Intersection, number 5. I want to know where those two graphs meet. So I'm going to press number 5. Second calc, above trace, second trace, number 5. Now it's going to ask you 3 questions. You really have to answer 2 of them. Well, actually, you really don't have to answer any of them. But first curve and second curve. Now, I only put 2 curves in my calculator, so you can be like, heck yeah, enter, heck yeah, enter. The last one says guess. Sometimes you don't have to worry about this, but there are 3 intersection points on this graph. So we just need to make sure we are closest to the intersection point that we want. You can either scroll using the arrows, or you could guess a specific number. So you could be like, I think it's around 1, and press 1, enter. If you just scroll, just press enter. Notice that intersection point is not at 1, and I'm sure they did that on purpose. So we're going to copy down that entire number right there, the X value. So 1.0328319. Yes. Is anyone annoyed by writing it down? All right, let's say you're annoyed by writing it down. Would you like to make your calculator remember it instead? All right, here's a way. So one way you can do this question. What's up? And you did the same steps I did? You did second, trace, intersect, enter, enter, guess. Check that your functions are plugged in correctly. All right, let's say you want to store this. So one option, you can write that number down. You can just use that entire number in your bound. If that makes you mad, you still should write down what that number is on your graph. But let's say you don't want to type it again. If I found my intersection and I go back to the home screen, I can press X, stow at the bottom, and store this as a letter. I'm going to store it as A.
I'm sorry, can you do that one more time?
Yep, so I'm going to take X, that's the number in my graph. I'm going to press stow, just second quit at the top, or just rage clear until you're there. And then I'm going to do alpha A.
How'd you get that arrow?
Stow at the bottom.
Sorry.
You're good. So what that will do for you is you have now stored that guy as A, and it will not change it until you tell it another value to store as A. That can be really advantageous because if I do a question like this on the AP exam, I might use that intersection point in A, B, C, and D, like all throughout the free response problem. So it can be helpful to have that. All right, if you label this number A on your paper, you can use it as you're doing your integrand. That second guy would have a value of A, the intersection point, to 2. Now, that's a perfectly fine way to do this question, but think about plugging that into your calculator. That would be a little bit obnoxious. So one way is to make sure that the top minus bottom, that it's going to subtract the right way and make that thing positive no matter what. Now, would you agree with me that if I flip-flop, if I subtracted the wrong way, all that's going to do is make the distance between them negative? Like if I take the height of F and minus G, if I subtract the wrong way, it's just going to make the answer negative of what it should have been. Say yes. So what is a way that I could make everything positive no matter what? Absolute value. So one way to get around having to do this is to absolute value my top minus bottom. It doesn't matter whether you do f of x minus g of x or g of x minus f of x. That will make sure that no matter which way you subtract, it's making that distance positive. So if you have a calculator, you can plug it in that way. Now, we could plug both of these in on the calculator. We're going to get the same answer. For the sake of plugging it in easily, I'm going to try to plug in the bottom one. I'm going to show you how to do it twice. So why don't you watch first, and then you can try it the second time. Anyone remember how to get an integral? Math 9. I'm going to go from 0 to 2. And then absolute value is math over to num. And do abs. And then I want f of x minus g of x. I remember I put those in y equals, so I'm going to use my alpha trace. y1 minus alpha trace y2 dx. This might take a hot second because we're asking it to do a heck ton of mathematics. And I get a value that is slightly north of 2. Makes sense? It's positive. Seems about the right size. Again, if you wanted that, James is going to tell me to shut up in like 20 seconds, but I'm going to just do it anyway. I could also use my alpha here if I wanted to use the bound, so plugging it in the first way. I think we were y2 minus y1, because g of x minus f of x for the first one. I'm going to do both of my integrals this time, just to prove that it'll work. I should have been more up. And then alpha trace.
How do you type in y1
Alpha trace.
Where's the num button?
Math. So math, scroll to the right. All right, if I plugged this in correctly, huzzah. Now, notice our calculator is a little bit bad at approximating towards the end of this, but we only need to be accurate to 3 decimal places. So 2.004. That's not what you were supposed to say to me. Shut up. All right. Cool. I'm going to be done now. I'm going to put up some visuals of what we're going to be learning in the rest of the unit. If you are feeling stressed, they are quite calming to look at, I think. We're going to be finding volumes for the rest of the unit. Most of these questions, though, we're going to do a lot of free responses. Start with part A being that. So we'll practice these later. All right, it is currently 12:26. At 12:53, I want your problem set, whether it's done or not. If it's already done, I'll take it. Go. Thank you, Lily. Why? You had I checked it all this morning.
I know, but I still feel. Okay, may I use the button?
Yeah.
Oh, yeah. I've taken 6 hours. Let's see.
man. Oh, I forgot they got rid of them. Oh, no.
My grade's not horrible right now, so I'm not, that's the reason I'm dropping it down because I don't think it's worth it. What about, did you sign up for the Canada thing? Yeah, but I don't think yeah, so. Well, if you drop it, it's not.
Yeah.
I finished this page, except for this
Okay.
I could just take, I just go.
Is this like the
This
right?
guy needs a user.
Yeah.
This 8 is actually a 1/8. So I would make sure you're matching 1/8, not an 8, because that 8 is on the bottom.
Oh. Okay, so it's divided
Yep. That would look good. You have bounds though. So I would take your integral. Also make sure you pull this over 2. Needs to come with that term. See how you have the sign of the 2x over 2. Make sure that over 2 pulls to that
That's
term.
over here.
And you need to plug in your bounds.
And then take the test.
Thank you.
What did you say was wrong with this one?
Know how you have the over 2 here for your U sub? You have a similar need for U sub here because the -5 has.
That's okay, by the way, right? Divide by 2 instead of
Mhm,
pulling it out. Okay.
The initial. Let's see what it, oh, I see. Why did you?
Where is my number of shapes? I love this chapter. It makes you feel so smart. Oh, there we go.
That's cool. Okay.
Oh, thank you. Yes. Thank you. Yeah, the volumes are cooler.
I didn't realize that I did it, but I didn't check it. Why did you choose?
Yeah, you can
I know. Let me grab the point. It's not letting me grab the point. Let me crash my computer by having a Google Meet open and then trying to change it to Smithcraft.
Okay.
Whee!
Can you check the please?
Sure.
Oh my god.
I don't remember that 3. Were they both 3? I don't remember that. I don't like your B or your, yeah, I don't like the B value. Will you check?
Was it 7?
Because this is 7B equals 14. So I don't like B equals 3. Other than that, I agree.
Alright. I'll take that and then.
Package. Yes. And yes.
Yeah. Or like.
I think so.
Wait. So, oh, right. Let me make sure. I knew what I was saying. I know. No, yeah, same. I literally did not know how to.
Let's see. Okay. Where am I? This is a lot of. You want me to simplify this?
I need you to plug in the right order, but technically if you don't want to simplify, you don't have to. However, keep going first.
So flip this the other way. I mean, I can just leave it like that.
If you would like, yes.
You want me to, or-
It is legal.
Okay. Like if this was on the test, this is fine. Okay.
I might ask you to simplify on the test, but it'll be in the directions.
So should I simplify for practice?
Not right now.
Okay.
I want you to finish your problem
I
first.
digress. For you,
Yes.
can you please explain to me the basic
Think -5 halves x instead.
-5? And I'm just deriving this? Isn't it just x?
What if it's like 2x?
Just x, right? Or my brain hurts so bad.
Think derivative means slope, right?
Yeah, yeah.
There's a line. What's the slope of 2x?
1.5. Just 2.
That's your derivative. Just the number in front.
I tried to integrate it. I took just x instead of just -5 halves. I'm trying to integrate it instead of dividing.
Yeah, so think of, like you would do the 1/2 for the 2x, think of reciprocal. So you would do like the -2/5 for the -5 halves.
Because if I was integrating 2x, it's 2 over 3x. Or, no, it's just x. I'm so tired. Okay, last thing before I run away. Is this better?
2 times the fourth is actually a half. So let's try half of a fourth
Half.
is an 8.
So 1/2 this. And then do I need to solve this too?
Yeah, you need to integrate u cubed. It's an easy integral though.
Is it the same as like a to the x?
No, think of like x cubed. It's like integrating.
Okay.
So then it's like, there's like a certain formula, it's like a.
Oh.
Are you allowed like?
Oh, yeah, that's just the-
Yes. Like.